Hey there. Let's talk about AI. When we use that term, what are we really talking about? Are we building a smarter kind of tool, or are we on the verge of creating a new kind of colleague? The answer isn't so simple, and it really defines two very different futures. So let's dig in and figure out which path we're actually on.
And really, this is the question at the heart of it all, because the answer separates the powerful little assistants we have in our pockets from the conscious partners we see in science fiction. It's the huge gap between simple automation and true, genuine autonomy. So here's how we're going to break it down. We'll start in the world of science fiction, then get real about what we have today. We'll look at the incredible ambition behind general intelligence, run into a major philosophical roadblock, check out a new scientific roadmap, and then finally, we'll unpack why this whole distinction is one of the most important conversations of our time.
All right, first up, let's start on some common ground, the AI that lives in all of our imaginations.
For decades, sci-fi has painted these incredible, and let's be honest, sometimes terrifying pictures for us of self-aware machines, and that has totally shaped our hopes and our fears about what creating human-like intelligence could mean. But to really understand where we're going, we have to get super clear on where we are right now, and the reality? It's way different from the myth. So let's pivot from that fantasy and get down to the reality. What is the AI that's actually running our world today? The AI we have is called Artificial Narrow Intelligence, or ANI for short. And the key word here, the one to really focus on, is narrow. These systems are specialists. They're hyper-focused. They're designed to do one thing or a very small set of things incredibly well, way better than any human ever could. But the catch? Take them outside that one specific area, and they are completely lost. And this isn't some far-off futuristic concept. It is deeply, deeply woven into our daily lives. Every time you ask Siri for the weather, or get that perfect movie recommendation from Netflix, or when your bank flags a weird transaction, yep, you're interacting with narrow AI. It's the engine running self-driving cars, and the chatbot that helps you out with a customer service problem. It's powerful for sure, but it's always specialized. And just how widespread is this stuff? Well, think about generative AI, the systems that can whip up text, images, and even code. That's a super powerful type of narrow AI. And get this, by 2025, an estimated 80% of companies all over the world will be using it. This technology isn't on the horizon anymore. It's a fundamental piece of the global economy right now. But, that specialist tool isn't the end of the story. Not by a long shot. The ultimate goal for a lot of researchers is something way more profound. This table right here really gets to the heart of that ambition. Just look at the learning type row for a second. Narrow AI is trained for one goal, period. And AGI, on the other hand, would learn on its own, and this is the crucial part, it would transfer that knowledge to other areas. That's the difference between a system that can play chess and a system that can learn from playing chess and then apply those strategic principles to, say, plan a corporate merger. That's the massive leap we're talking about. So, to boil it all down, we're trying to move from building a task-specific intellect to a universal one. One is a ridiculously sophisticated tool, the other would be a genuine problem-solving partner, one that could tackle challenges it was never even programmed for. And AGI wouldn't just be about following orders. As you can see from these characteristics, it would need actual common sense, the ability to think abstractly, and a real understanding of cause and effect. It would learn and adapt all by itself. The ultimate goal here is a system that isn't just intelligent, but might, one day, actually be self-aware. But, and this is a huge but, this whole ambition slams right into a massive philosophical and technical wall, the problem of genuine understanding. This question is really at the heart of the whole debate. If a machine can flawlessly perform a task, can we really say that it understands the task? Well, there's a famous thought experiment that helps us explore exactly that. Okay, so picture this. You've got a person who only speaks English, and they're locked in a room. Through a slot, they get notes with Chinese characters on them. Now, they also have this massive rule book written in English that tells them exactly which Chinese characters to send back out in response. So, to anyone watching from the outside, it looks like the person in the room is totally fluent in Chinese. It seems like they're having a perfect conversation. But here's the punchline from the philosopher John Searle. Despite producing all the right answers, the person in the room doesn't understand a single word of Chinese. They're just manipulating symbols based on a set of rules. And this is the huge challenge for AGI. Are our modern AI systems truly understanding things, or are they just incredibly sophisticated versions of that Chinese room?
So how do we build a system that actually understands instead of just mimicking? Well, a recent framework tries to move beyond the philosophy and proposes an actual engineering roadmap, a way to build and measure our progress toward a real AGI.
This new definition is a game changer because it's testable. It shifts the focus away from fuzzy concepts like consciousness and onto concrete abilities we can actually measure. Can the system acquire knowledge on its own? Can it reason? Can it transfer that knowledge to totally new problems? This turns a philosophical debate into a real engineering challenge.
This diagram here is basically the proposed blueprint. The big idea is to move away from a single, giant black box. Instead, you've got all these separate modules for different jobs, one for perceiving the world, one for reasoning, and so on. That cross-domain transfer core is absolutely vital. It's what lets the different parts share what they've learned. And notice that safety alignment layer at the bottom. The idea is to build alignment with human values in from the very beginning, not just tack it on as an afterthought.
And of course, if you're going to build it, you've got to be able to measure it. This framework moves way beyond simple pass-fail tests like, does it sound human? Instead, we get these concrete metrics. For instance, the transfer score would measure how well an AI that learns physics can apply that logic to a problem in, say, economics. The safety stability score directly measures its alignment with our values. This is how we go from a philosophical idea to a true engineering discipline.
Okay, so we've traveled from the sci-fi myth all the way to a potential new reality. Let's bring it all together and really understand what's at stake here.
At the end of the day, it really boils down to this. What we have right now are incredibly powerful, specialized tools. What we are chasing is a universal problem solver. The difference in what that could do and the potential impact it could have on our world, well, it's almost impossible to overstate.
You know, achieving AGI could unlock some incredible opportunities. We're talking about accelerating innovation at a speed we can't even imagine, creating near-perfect efficiency. But the risks are just as huge. A total loss of human oversight, massive job displacement, and the existential risk of creating a system whose goals are not aligned with our own. The stakes just could not be higher.
And so that leaves us with the ultimate question. It's not just about whether we can build AGI, but how we do it in a thoughtful and safe way. As we build these more and more powerful systems, the real challenge is to embed our values deep inside their code, to make sure that the next giant leap in intelligence is also a leap forward for all of humanity. Thanks for tuning in.